Hi guys, if you are viewing my channel first time, please subscribe to my channel for more updates on machine learning. Today we'll mainly discuss about an Ada Boost or adaptive boosting. It is one of the supervised learning technique in our machine learning. By using supervised learning technique, the prediction can be made. Ada Boost, the training and also prediction always follows the boosting technique. That's why we want to discuss the background of the ensemble techniques. Ensemble techniques are two types: bagging or bootstrapping aggregation, and second one is the boosting. Okay, bagging or bootstrapping is the parallel process, boosting is a sequential process. For example, in case of bagging or bootstrapping aggregation, I have taken the example dataset contains 1000 samples. Out of 1000 samples, 700 samples I have taken original training data. This out of 1000 I am taken 700 for the training data. This training data set I am dividing into the multiple data sets in the first step, creating multiple data sets. Data set 1, randomly 400 samples I have taken from the this training data, that I am mentioning it as data set 1. Similar way, data set 2, data set t minus 1, data set t. And the second step, we need to build the algorithm like a classifier or regression algorithm. We need to build by using this data set. Okay, I am able to build the just models, classifier or regressor. Similar way for all the data set I am able to build. After building the models, and we need to combine the results here in the last step. For example, in case of classifier, which is having highest vote, that I am selecting it as predictor. Similar way, in case of regression, we need to aggregate all the results. That result I am taking for the prediction. This is a way that training and also prediction using the bagging or bootstrapping aggregation. Mainly, random forest follows this bagging or bootstrapping aggregation. And here Adaboost always follows the boosting technique. That's why we want to discuss mainly boosting technique here. Okay, here in the first iteration, I'm able to classify only three blue samples exactly, but two blue samples I classified it as red. Okay, these are misclassified. These two samples are misclassified. That's why I'm going to the next iteration. What and all the misclassified I want to target in the next iteration, so that I'm able to classify exactly these two. But other three I classified it as red. Okay, these are misclassified in the second iteration. That's why I'm going to the next iteration. Okay, I'm able to classify all the blue samples. That's why these are misclassified. That's why I'm drawing line here. I'm able to identify all the blue samples, but also and also red samples also I'm able to classify as blue samples. These four are misclassified. Okay, these 1 2 3 all are weak learners. Okay, here I'm combining all the weak learners into the strong learner. Okay, here in the fourth iteration I am able to predict exactly by using these three weak learners. So that these three weak learners I am able to combine, so that I am able to get the exact prediction. This is a way boosting algorithm will work. Okay, similar way we'll discuss using the Ada Boost, how the training and also prediction using the Ada Boost. Ada Boost algorithm can be used for both classification and regression problems. This is a main point. And we'll discuss how the Adaboost technique, the training and also prediction using the Adaboost. Okay, here I have taken the three decision trees: decision tree 1, decision tree 2, decision tree 3. For example, in the decision tree 1, I just passing 10 samples, 5 positive and 5 negative. And for the first decision tree, it is able to just classify only 2 positive exactly, but 3 positive classified as negative. These 3 are misclassified. In case of Ada Boost, what and all the misclassified samples, we are going to increase the weight. After increasing the weight, we are passing to the next decision tree. Okay, here I am drawing line here, so that here I am able to capture all the positive samples, but three negative I am able to classify it as positive. Okay, these three are misclassified. That's why I'm going to the next decision tree. I want to increase the weight of these three misclassified objects. I'm able to increase the weight, and I'm going to the next iteration. I'm drawing a line here, and this negative I classify it as positive. This is a incorrect prediction. Similar way, I draw a line here. This two positive I classified as negative. Okay, this is also misclassified. Okay, these three weak learners I am just combining results here to get the strong learner. Okay, this is a way the Ada Boost training and also prediction. Okay, prediction we'll see. For example, decision tree 1, it is giving the result 1, and decision tree 2, it is giving result 0, and decision 3 results giving 1, which is maximum voting, that I am selecting it as prediction in our Adaboost. Similar way in case of regression, just we need to combine, we need to aggregate all the results, that I am selecting it as prediction. Okay, this is the way, the training and also prediction. Here in case of Adaboost, which are all having misclassified samples, we need to increase the weight, and we'll discuss how we are going to increase the weight by using the formulas. Okay, here the background we'll discuss here. Here I have taken one more example here, and we are going to increase the weight what and all the misclassified data. Okay, here we'll discuss, we have three independent features, x1, x2, x3, and one dependent feature. Okay, here for example, let us assume my box one is classified as like this. For example, one is misclassified, that's why we are going to increase the weight of the sample 2, but the other samples I want to just minimize the weight. Okay, similar way we want to see how the training and also prediction. The step 1 here, we want to assign the same weight to all the samples. Initially, first decision tree, I don't know which and all samples are correctly or incorrectly classified, I don't know, right? That's why I am just averaging the all the weight by using this formula, w equal to 1 divided by n means number of samples. For example, if I count all the samples, I got 10. 10 means 1 divided by 10 is my weight of the first sample. This is the second sample, also similar way. Here I am just assigning the similar same weight to the all the samples in the first step. This is the first step. Second step, okay, here if I want to this data set, I am passing to the box 1. This is a decision tree 1 I am passing. It is classified as 1 is misclassified, 0 classified as 1. This is a misclassified. Okay, that's why we want to calculate the new weight for the next data set. Okay, that's why here new weight equal to wi equal to w of I minus 1 multiple of exponential plus or minus alpha. Okay, here to increase the weight, we need to use this formula. Plus or minus alpha means we need to calculate the performance. Okay, to calculate the performance, here alpha t equal to 1 divided by 2 log of 1 minus total error. For example, what is the total error? This is my error, total error. For example, out of 10 samples, only one is error. That's why 1 minus total error means 1 divided by 10 means 0.1 divided by 0.1. This is the way I am calculating the alpha. After calculating the alpha, we can calculate the new weight. Okay, new weight equal to old weight. What is the old weight? 1 divided by 10. This is my 0.1. If I see here 0.1 exponential of here alpha, what is my alpha is p19. Okay, this is my alpha. Okay, here I am just classifying the wrong weight using this formula. Plus alpha is my wrong classified weight, and the remaining weights are correct classified. Okay, here I need to use the minus of p19. This minus of alpha I need to use to get the correct classified weight. Okay, similar way I am just calculate, I just mention the correct weight. Here correctly classified weight is 0.575. These are the correct classified weight. Okay, here misclassified samples, I need to increase the weight. That's why I am using this formula to increase the weight. What and all the misclassified samples, we need to increase the weight and pass to the next iteration. Okay, the next one, we need to normalize the weight. Okay, to do the normalization weight, we need to add complete weight here. Just I am adding all the weights here. Okay, then we need to divide by this main weight. This one divided by main weight. See here G13. This is my G13 divided by total weight. Okay, here I am just normalizing all the weights. I got this data, normalized data. Okay, this normalized weight I am passing to the next iteration. So that, for example, if my weight is 0.6, so that I will take the misclassified data directly. Okay, this is the way we need to identify in the next iteration what are all the misclassified data, what are all the wrongly classified. By using the weight, we are identifying the wrongly classified objects that we are classifying exactly in the next iteration. This is the way what are all the misclassified samples, we are going to increase the weight and passing to the further iteration. This is the way Ada Boost the training and also prediction. Okay, prediction is the just average or maximum voting based on the, if it is classifier, taking the maximum vote. If it is regression, just average the all the votes. Okay, first step, just we need to understand the three steps here. First step, we need to assign the uniform weight. The second step, we need to calculate the new weight using the w equal to w of I minus 1 old weight multiply of exponential plus or minus alpha. This is step 3. Step 2 means we need to calculate the Gini or entropy for the classifier, for the standard deviation for the regression. Let us assume, for example, this is my classification. Okay, we need to calculate the Gini or entropy for the this x1 x2 x3 feature. Okay, then which is having the lowest Gini or entropy, then that I am selecting it as first decision tree. Okay, first step I know. Okay, just we need to assign the similar weight to the all the objects. Why? Because I don't know which and all correctly or wrongly in the first iteration. That's why I'm just assigning to the uniform weight to the all the samples. The next step, we need to choose which feature is I'm going to select in the first decision tree. That's why we need to calculate Gini or entropy for the classifier. In case of regression, we need to calculate the standard deviation. Okay, then we can calculate which feature having the having the lowest Gini or entropy, or in case of regression, which is having the lowest standard deviation, that we are selecting it as first decision tree. Okay, I know the which one we need to choose in the second step. And the third step, we need to increase the weight using the formulas. This is the way we need to train our predict using the Adaboost. Okay, then we'll discuss what is about the regression and also classification using the in our Jupyter lab. Okay, here okay, we'll discuss mainly in the Adaboost Classifier. Here import, this is a Jupyter lab I have executed already. Just I am explaining the all the steps here. Import pandas as pd is my import library. Here dataset equal to pd, this is my pandas, pd is my pandas, read cs is my method. I'm just passing my kyphosis dataset. Okay, here this dataset I am using for the classifier, Adaboost classifier. Why? Because this target data contain categorical or binary, we can apply the classification algorithm. And here x1 x2 x3, three independent features, one dependent feature. This data set I am passing for the training and also prediction. Okay, for example, here we have to divide into the four parts. Here first part, model training. 70% of data I'm using for the training data, and the remaining 30% I'm using for the test the model. Okay, that's why here this is the y column. That's why I'm mentioning it as y train. This is the x column, x train. This complete blue. And similar way, this is a y test. If it is y column, y test. These are remaining 30% for the test the algorithm. That's why y test and x test. Okay, here I am dividing into the four parts. If you want to train our model, we need to pass the x train and y train to train our model. And to test our model, we need to pass the x test, then we'll get the y prediction. Then we'll calculate the what is the actual data, what is my prediction data. Okay, then we'll discuss how the program here. Okay, data set equal to pd read csv is my method. I am passing the same kyphosis csv here, kyphosis. And here kyphosis my first column, age start number x1 x2 x3, this is my target y. Just I dataset dot head means it will display the first 5 records. And here just I am mentioning, I'm just dropping the here kyphosis, just dropping the kyphosis this column, the first column, and I am just treating it as this is my x age number start, and y is my kyphosis, only this column is my y. Just I am printing what is my x, age number start my x age number start, and y is my only kyphosis, only this data absent or present. Okay, here I just have done the pre-processing, which is my x, which is my y, age number start is my x, and kyphosis is my y. And after that we need to split our data using the sklearn. Okay, from sklearn model selection import train test split, this is my method to split the data accordingly as we discussed four parts. Okay, if it is my training data, x train and y train. Similarly, if it is my test data, x test and y test. We need to divide into the four parts. Just I am passing my what is my x and what is my y. Already we have done the pre-processing here. I know already what is my x and what is my y. Here I am mentioning my test size is my 0.3. That means train size is 70%. Here I have taken the train size is 70% and the test size is only 30%. Okay, here I am mentioning the same random state. If I want to get the always constant prediction, we need to initialize with some value. Otherwise, we'll get the always different prediction and each and every time execution of our model. And here I got the all the x10 and x test, y10 and y test. I got the four parts like already we discussed. X-train and Y-train and X-test and Y-test. We got all the four parts by using train test split method. And after that we are using this is a Ada Boost Classifier is one of the ensemble technique. From sklearn.ensemble import Ada Boost Classifier I am importing, and also to calculate the accuracy score I am importing from the SK library itself. Okay, here in my object I am just accessing my class Adaboost Classifier, and here I am just passing my fit method. This is my object dot fit. Just I am passing x10 and y-train to train our model. Just I am passing x10 and y-train for the model training. Just for the model training is done by using this step. Okay, next here we need to discuss what are all the important parameters in our Ada Boost classification. Okay, SAMME.R. Okay, this is a real boosting algorithm. It is used to calculate the weights of our misclassified data. By using this algorithm, we used to calculate and also go for the next iteration. And here base estimator, here we are using already we discussed in case of decision tree regression, the max depth will be always 1. If you see here one root and only 2 leaves, this my max depth is only 1. Okay, if I want to select the each feature, only I have to use one root and only 2 leaves. This is the max depth is only 1 in our classification. Okay, here max depth in our classify max depth always 1. Okay, here this is my none. Always base estimator is none, means always my max depth is 1 in our Adaboost classification. And the learning state, for example, defaultly it will be 1. The weak learner, okay, contributes the weight of the weak learner. Defaultly it will be 1. Learning rate will be always 1 defaultly. And here estimators, how many decision trees to be used to build our Adaboost classifier. Max defaultly it will take 50. For example, in our algorithm it might take 2 or 3. Maximum it will be 50 as per initially estimators maximum 50. As per our algorithm it may take 10 or 15 based on our use case. Okay, next random state. If I want to get the always same prediction, so that random state I can initialize it with none. Okay. Okay, next one here I want to predict. Here this is my object model. 8db is my object, same object. I'm just I want to predict my algorithm by using x test. Here I'm just passing the x test and I will get the y prediction. This is my y prediction. This is my ADB prediction. This is my y prediction. Just I am passing the x test, then I will get the prediction of my model. Object dot predict is a method. Just I am passing the x test, then I will get the predictions. Okay, now I know the what is my y test and y prediction, so that I can pass and I will get the what is the actual prediction, and also what is the actual data, what is my prediction data. Here I am calculating confusion matrix equal to PD is my pandas. I am using the pandas library here, and crosstab is my function. Okay, crosstab is my API to just display as per the matrix. That's why I'm using this crosstab to display the what and all the correct prediction, wrong prediction using as a matrix. Okay, that's why I'm using this crosstab. I'm passing y test, and ADB predictions is my prediction actual data. This is my y prediction data. ADB predicts the prediction data. This is my actual data. This is my prediction data. This is my rows actual. This is my actual data. I am representing in rows, and the columns I am representing in the prediction data. This is my prediction data. Okay, here import Seaborn as SN heat map. I am just passing this confusion matrix. Annotation true. I want to display in different colors so that we can mention this one. Okay, here to understand this matrix, actually is absent, and prediction also absent. Okay, this is a correct prediction. For example, actually is present, and also prediction also present, this is also correct prediction. And here see, actually is present and prediction is absent, this is a wrong prediction. And actually is absent and prediction is present. Okay, this is also a wrong prediction. These two are correct predictions always, these two are wrong prediction. Okay, out of 25, okay, only 21 are correct predictions, 4 are wrong prediction. Okay, if I calculate 21 by 25, then I will get the 0.84. Similar way we are using the accuracy score, just I am passing the y test, and ADB prediction, I got the prediction from the x test. Okay, just I am passing these two and I will get the accuracy as we discussed here. 21 divided by 25, I will get 84% of the our accuracy. Okay, here mainly we are using the algorithm SAMM.R to calculate the weights of our each and every misclassified data. We are using this model, this algorithm. Okay, similar way we'll discuss Ada Boost Regression in the next here in the next Jupyter lab. Here just I am importing pandas as PD. Similar way I am just reading the salary data.csv. Here I am dividing into the point 0.5 data set. Okay, point 0.5 I am using for the training, and here I have only 30 samples. Out of the 30, 15 I am using for the train the data, 50 samples using for the test the data. Here X train and Y train for the model training. X test, if you pass, then we'll get the Y prediction, then we'll calculate the accuracy between the Y test and Y prediction using the metrics. And we'll see what are all the metrics to be calculated. In case of Ada Boost, we just calculated the confusion metrics we calculated. Okay, and similar way in case of Adaboost, we'll see how what are all the metrics to be calculated. Here just I'm accessing the salary.csv using the read csv dataset.head. Here I'm displaying the first 5 records. Here years of experience and salary I'm displaying 1.1, 1.3, right? First 5 records I'm displaying it here, and I'm mentioning what is my X is my years of experience, Y is my salary. Just in the data pre-processing I'm mentioning what is my X and what is my Y. Next we'll split the data by using the train test split. Using the sklearn model selection, I am using this method, train test split method. I am just passing X and Y. I am just mentioning train size is 0.5, that means test size also 0.5, and that's why I am dividing into the 0.5 0.5 here. First 15 samples I am just mentioning it as train, and remaining 15 samples for the test. Okay, next random state always should be mentioned, otherwise we'll get the different predictions. Okay, that's why here I'm dividing into the X train and X test, Y train and Y test. I got the 4 data here, and using the ensemble technique, here I'm using the Ada Boost Regressor. Here this is my object, I am accessing my class Ada Boost Regressor. Here Ada dot, this is my object dot fit is my method in our Ada Boost regression in my class. Okay, with in that method I am just passing the X train and Y train to train our model. Okay, here we'll discuss what are all the important parameters here. Here we are using the loss function to calculate the weight for the what are all the misclassified objects. We are using the loss function here. Here if you see here, linear loss function we are using to identify the weights to increase the weight. Here defaultly, as we discussed, decision tree. Okay, here just I wrongly just copied decision tree. This is a regressor. The max depth in the regressor will be 3. Only the difference in Adaboost classifier, the max depth is always 1, but in case of decision tree regression, the max depth is 3. These are only the difference, and remaining all are the same. So only the algorithm also different. Here we are using the loss function. There we are using the SAMMR.R function, real boosting algorithm. Here we are using the loss function to update the weights for the misclassified data. Okay, and learning rate always defaultly it will be 1, and estimators here also we are using the 50 decision trees to train our and also prediction using the 50 decision trees maximum, but based on our data it will try to train and also prediction and also predict. Here y prediction I am using equal to my class ADA is my object. I am just accessing my method predict, just I am passing my X test. Okay, here just similar way, X train and Y train we passed, and the model training is done. Similar way I'm just passing X test, I will get the Y prediction here. Here y prediction I got, I'll just passing the x test, then I will get the y prediction. Then we'll calculate the regression scores here. Here in case of regression, we need to calculate the mean square error and r square score we need to calculate to tell how much our model is efficient. Here mean square value, I'm just passing the y test and y prediction. To calculate the mean square error is my method, one of the scalar method. I'm passing the y test and y prediction. We get the MSC. And r square, also we have this other method, just I am passing the y test and y prediction, we'll get the r square. And similar way, if I want to get the RMSE, just I need to apply the SQRT, one of the mathematical function. I will get the RMSE also, just I am applying square root to the MSE, then I will get RMSE. Okay, here I am just displaying the mean square error and root mean square error and r square value. This is a 92% means. Okay, here 0.92 means 92% efficiency we got by using the Ada Boost regression. Okay, similar way, by using this classifier we got 0.84. Okay, mainly this Ada Boost classifier, mainly this Ada Boost method mainly we are using for the classification techniques, not mainly in regression. Okay, the conclusion, this Adaboost mainly used for the classification. Okay, how we were discussed right here in the how the calculation and how we are increasing the weights, how we are passing to the next decision tree. Okay, that's all friend, thank you for watching. Thank you friends, thank you for watching.